Hello, calculus fans. Okay, let's try to evaluate this integral. Integral from 2 to 3 of 4x over x cubed minus x squared minus x plus 1 dx. All right, the first thing we got to do is factor the denominator. Sometimes the problems are given to you with the denominators factored. In this case, whoops, not factored. So I'm going to let q of x be that denominator so that I can work with that. I want you to notice something. If you plug in 1 into q, you're going to get 0. And that means something. We have something from pre-calculus called the Factor Theorem. And if 1 is a root of a polynomial, that means the corresponding thing, x minus 1, is a factor. So that means we can factor out x minus 1 from this thing here. That means if we take x cubed minus x squared minus x plus 1 and divide that by x minus 1, we should not get a remainder. So if you were to do the long division, it would end up looking like this. I don't want to go through the nitty-gritty details of long division. This is something that if you're not sure about, we can talk about it in class and try to work out how the long division works. Notice that we get a remainder of 0. That's good. We want a remainder of 0. So that tells us that q of x is equal to x minus 1 times x squared minus 1. So here's the x minus 1, and then here is the quotient, and so that's why we have the x minus 1 here. Notice, of course, that x minus 1 itself factors, and it factors as x minus 1 times x plus 1. So now we have our final factorization of the denominator. The denominator factors as x minus 1 squared times x plus 1. All right, so we're going to do a partial fractions decomposition on the integrand. So our 4x over x minus 1 squared times x plus 1 will look like a over x minus 1, b over x minus 1 squared, and c over x plus 1. So we had to have two terms here corresponding to x minus 1 because it is a repeated linear term. And so we have to repeat in the decomposition for every power of that repeated linear term. Okay, we're going to use Heaviside cover-up. We're going to get b equals 2. You know, maybe you should pause now and try to use Heaviside cover-up to compute c. Go ahead, pause, and try to calculate c using Heaviside cover-up. You're going to end up with c equals -1. Now, Heaviside cover-up cannot be used to solve for a, because if you have a repeated linear term, Heaviside only works for the highest power of that linear term. Okay, so we can't use Heaviside for a. We're going to have to go back to our other techniques. Okay, so let's plug in the value of b and c we have, and then we're going to try to work out what a is. Now I'd like to give you a little bit of a different technique for computing a. I want to plug in something and solve for a. Now there's only a couple of things that we cannot plug in. We cannot plug in 1 and we cannot plug in -1 because we'll end up with zeros in the denominator. So I can plug in anything else I want. So if I can't plug in 1 and -1, certainly I'm just going to plug in 0. I mean, after all, 0 is such a nice number. Okay, so if we plug everything in, plug in 0, then we get an equation that looks like this. So I've plugged in a 0 everywhere for x, and now I'd like to try to solve for a. So let's clean this up. So 0 is equal to -a plus 2 minus 1. So if you work all that out, that's what you should get. So that gives us a equals 1. All right, so here's our decomposition. That the integrand that we started with, which was 4x over x minus 1 squared times x minus 1, is equal to 1 over x minus 1 plus 2 over x minus 1 squared minus 1 over x plus 1. And now let's go back and deal with the integral. So, you know, up to this point, we haven't even done any calculus on this problem. It's all just a bunch of algebra. Now we're going to do the integral. Okay, so we should get something that looks like this. Again, this is using one of these substitutions without making a substitution. This is something that you should look at very carefully if you're not sure about how to do it. You should break it up into 3 different integrals and evaluate each piece separately. All right, so I'm going to go ahead and plug in the 3 and the 2. All right, again, I don't want to go through the gory details of this. If you clean it up, you end up with something that looks like this, and all that cancels out, and you're just left with 1. You know, this is where it's important that you watch these videos while you are working everything out with pencil and paper. You do not want to watch these things passively, because I went through a lot of things fairly quickly here that I'm expecting that you should try to work out on your own. Okay, that's all for now.